Welcome everyone. In today's video, we will talk about tangent lines, velocity, and we will give the definition of the derivatives. The tangent line to the curve y is equal to fx at the point PAFA is the line through P with slope. This limit is really important to us because our derivatives, our tangent lines, our velocity, everything is based on this limit. So we should not forget this limit. Limit of fx minus fa over x minus a as x approaches to a, provided that this limit exists. This limit gives my slope to me, right? I know a point, I know the slope. What was my formula? Y minus y0 is equal to m times x minus x0, right? When I put the values in this formula, I get the equation of my tangent line. Find an equation of the tangent line to the parabola given to us x squared at the point 1, 1. Okay. I need the slope. I know a point, I need the slope. How am I gonna find the slope? By the limit that I learned, right? X approach to a. Let's write it. Fx minus fa over x minus a. And now, x approach to, what is my a? My a is coming from here, right? This is my a and this is my fa. So my a is 1. Fx is x squared minus, what is my fa? My fa is coming from here, as we said, minus 1 over x minus 1. Evaluating this limit is really easy, right? The limit is approaching to 1. We can write this as x minus 1 times x plus 1 over x minus 1. Cancel these out. The limit is 2, which is equal to my slope. Now I know the slope, now I know a point. Y minus y0, 1, is equal to 2 times x minus another 1 from here. Let's play with it a little bit, why not? 2x minus 2, y minus 2x plus 1 is equal to 0. We have another expression for the slope of a. How are we gonna do it is, first of all, what is our slope? Fx minus fa over x minus a, right? We will let h to be x minus a. Then, when I send the a to the other side, x will be equal to a plus h. Now I put the values inside this. For x, I have a plus h, which is here. Fa remains still, and for my denominator, my x is a plus h. A plus h minus a's will cancel out, so my m is equal to limit of f a plus h minus fa over h as h approaches 0. Find an equation of the tangent line to the hyperbola y is equal to 3 over x at the point 1, 3. Let's use the new limit definition that we learned for the the slope. For our slope, a plus h minus fa over h. Now let's put the values. For a, I have 1, so f1 plus h minus f1. This is over h. For 1 plus h, of course, I need to plug it in here, so therefore limit of this function is h approaches 0. 3 over 1 plus h minus f1 is 3 over h. I need to write these in the same denominator, so let's expand this with 1 plus h. 3 minus 3h over 1 plus h over h. Cancel these out. Limit negative 3h. Now I can write the denominator as 1 plus h times h. Cancel these out. Now it's really easy to plug this in and see that this limit is equal to negative 3. We did not finish. Okay. I have a point. I have the slope. Now the only thing I need to do is putting the values negative 3 times x minus 1. Let's write it in a better form. Y minus 3 is equal to negative 3x plus 3. And from here, y plus 3x minus 6 is equal to 0. Find the slopes of the tangent line to the curve y is equal to root x at x01, x04, x09. Okay, we have 3 points. Instead of evaluating the limit 3 times, let's say our a is equal to x0 and limit of fa plus h minus fa over h as h approaches 0 will be equal to limit of f x0 plus h minus fx0 over h. Let's write these functions under the root now. X0 plus h minus root x0 over h. We talked about how to solve these limits in algebraic simplification video, so we will multiply this with the reverse sign of it. Now, this is h, not x. x0 plus h from here. If I multiply this with this and multiply with this, this with this, they will cancel out, so we don't need to write that. Minus x0 from this. And this is over h times root x0 plus h plus root x0. These will cancel out, so therefore this will also cancel out with this. And now, when I plug this in for here, 2 root x0. So this limit is equal to 2 root x0. The thing is, to evaluate the limit, we need the slope and a point. The point is not giving to us, so let's find the points. Let's change the color too. I like red a little bit. x0 is 1. What is my function? Y is equal to root x, right? So therefore, my first point, let's call it x, is 1, 1, right? Because when I plug it in, root 1, 1. And the other thing I need is the slope, which is when I plug this in, of course, 1 over 2. X minus, not x minus. It doesn't matter, but I like starting with the y is equal to 1 over 2 times x minus x0 is also 1. I will not go further because we have 2 or more of these. The next one is 4. Plug the 4 in, it's 2, right? So what is my m? 1 over 4. For this, 1 over 2 times 2, 1 over 4. I have the point, I have everything ready. Y minus 2 is equal to 1 over 4 times x minus 4. Last point is 9, right? It should be, yes, it is 9. Good. Plug this in, 9, root of it, 3. What is my m? 1 over 6. Let's write the formula. Y minus 3 is equal to 1 over 6 times x minus 9. Now, we will have a look at velocities. We will look at the relationship between distance, rate, and time. If you took any physics classes, you are already used to these probably. But first, let's remind ourselves that distance is equal to rate multiplied with time. So we can say rate is equal to distance by time, which is speed, right? Suppose an object moves along a straight line accordingly to the function s is equal to ft. S is the direct distance of the object from the origin at time t. So we have an object Let's say this is where our object starts. And at time t, it is here, right? And at time a plus h, at time a, it's here, and at time a plus h, it's here. There's a distance between. The distance between is fa plus h minus fa. Why? Because it's moving according to this function we have. And the time is obviously a plus h minus a is h. So average velocity distance over time is fa plus h minus fa over h, which is the same as the slope we can clearly see. So we will say va, which is our velocity, we will say this is equal to limit of fa plus h minus fa over h as h approaches 0. Suppose that a ball is dropped from the upper observation deck of CN Tower 450 meters above the ground. What is the velocity of the ball after 5 seconds? How fast is the ball traveling when it hits the ground? The distance in meters fallen after t seconds is 4.9 t squared. So our ft is given to us, 4.9 t squared, right? What is the velocity after 5 seconds? How are we gonna evaluate this? To evaluate the velocity, we need to evaluate this limit, right? Over h. So let's use the function we have. What is it? 4.9 times a plus h squared minus 4.9 a squared over h. What can we do? Let's write this under the 4.9 parentheses and let's expand the square. We have 4.9 times a squared plus 2a times h plus h squared. We said we will take it under the 4.9 parentheses minus a squared. This is over h. Now let's see what do we have inside the parentheses. These can cancel out. If we take this under the h parentheses, we can cancel an h2. So the limit of 4.9 h, I'm taking the h out too, 2a plus h. And this is over h. Limit approach to h approach to 0. Cancel these out. Now I can plug this in here, right? So 4.9 times 2, 9.8a is my velocity. The question is asking us the velocity of the ball after 5 seconds, which is 9.8 times 5, which is 49. This is how we answer the A. For the B, how fast is the ball traveling when it hits the ground? First of all, the distance when the ball hits the ground, this is our ball, let's change the color. Oh, we don't have enough space. Okay, let's clean this part. Oh, I need that. Okay. T squared. Okay, how fast? So if this is my ball that I throw from the CN, when it hits the ground, the distance will be 450 meters, right? So from saying 4.9 t squared is equal to 450, we can find the time, right? 450 over 4.9 is equal to t squared. From here, we need calculator, of course. Here, this is over 4.991 root this, root 91. Approximately, let's say 9.5. And the speed is the question. So what are we gonna do? Of course, this is not t squared. Okay, wait. So from here, t is approximately 9.5. The time is known, the velocity is known. What are you waiting for? 9.8 times 9.5. Approximately again, the answer we will get 9.8 times 9.5 is 93.1. So the speed is approximately 93.1. We talked about everything. Now we will name the things we did. The special limits we learned today is used in a lot of fields, right? We used in velocities, we used in we use in mathematics, we use it in physics. We did not talk about it in this video, but we use it in particular speeds in everything. So because of that, we gave a special name to these limits. We call it derivatives, and we will show it as derivative of fa, like this. There's other notations for it, but we will see them in other videos. Derivative of fa is equal to this limit or this limit if this limit exists. Now with this limit formulas, let's find the derivative of fx is equal to 2x plus 3. It doesn't matter which one you use. I want to use fx minus fa over x minus a as x approaches to a. Fx is 2x plus, let's not do that. Let's write it here. 2x plus 3 minus 2a plus 3. This is over x minus a, right? Cancel these out. The limit that I have transforms into 2x minus 2a over x minus a. And it's pretty easy to see that I can cancel the x minus a's if I take the numerator to the two parentheses. Limit of 2 times x minus a over x minus a as x approaches to a. Cancel these out. This limit is equal to 2, so therefore I'm going to say the derivative of fx here, the derivative of the function given to us is equal to 2.